Hi there, it's Gal. In this video will be a quick extension to perspective correction. In one of the last videos I showed you how to correct perspective using a detected grid, and in this video I'll show you how to correct perspective using a reference image. Let's load two EL images of the same device but image at a different time. You see, it's the same device but there is some translation going on. If you would calculate a difference image, let's do this, add display, difference image, let's show the preferences and let's go to console. I'll explain in a second what I'm doing right here. Display 0.layer1 minus display 0.layer0. Okay, so what did I just do? What you see here is a Python console. Okay, a Python console has all the normal things a Python console has. You can do some arithmetic, you can, I don't know, take a look what kind of methods and functions we have in our current display. By the way, this is the current display. All these tabs here refer to the visible displays. So this is the tab for display 0, this is the tab for display 1, and this is the console for display 1, and D is a short for the current display. If you want to exit and access another display, we give it the number. If you want, for example, to access this display, it's display 0. I'll say our own display would be display 1 or just D in this case. If you want to exit the layers, the image layers in every display, we type d.l. d.l, as you see, contains one image of this shape. If we would have multiple images, as for example in display 0, we get all the images together if we just type d0.l. Sorry, that was a typo. d0.l. If we only want to access a specific image layer, for example the first image, we type d0.l, 0.l, 1.l, whatever the number is. Let's do this, and we see this is one image, and this is two images. Okay? So what I actually did here in the very beginning was this thing. This display layer equals display 0 layer 1 minus display 0 layer 0. And you see this is a difference image, but because there is some translation between the two PV devices, the difference image is basically not usable. So how do we correct for this? Of course we could just say, let's open correct. Let's do the same thing as the last time. Let's just click perspective correction without doing anything, and we will get eventually a detected grid and the corrected result. But this is not what we want to do here. What we now want to do is we want to say, okay, I would like to correct the current display layer 0, using a reference image. And this I get from display 0 and it's reference image 1. That's all I do. Let's activate it and let's hope for the best. What's going now on in the background is some pattern recognition and pattern comparison. In result, we get a perspective corrected image. And we can repeat our difference image calculation. I will now create a new image layer. I call it display layer 1. And I will now subtract from display 3 layer 0. I will subtract display 0 layer 0. Is it the right one? No. Display 3 layer 1. And here we go. So, as you see, this difference image now is actually usable, and we can now finally see what happened in between the last time. So we have some brighter images, we have some brighter areas, we have some dark areas. We see there's a lot of oscillation going on next to cracks. And as you see, perspective distortion is barely not visible anymore in comparison to this one. Okay, so this is the difference image without perspective correction. This is with perspective correction. If you need higher precision, you can also activate this thing called subpixel alignment. It's still quite in development and still quite slow, so only use it if you need high precision output. That's how to create a difference image on two different measurements. I hope you enjoyed it. Bye bye.